All right, welcome back. We're at episode 25 now. We're going to take another look at applicative functors, and we're going to look at the apply, or as we have it in Ram to Fantasy, it's actually app. We're going to look and see how that's a little bit different intuition than lift, but it ends up doing the same thing, just kind of a different way of looking at it. I'm Reed Evans. I'm on Twitter at Reed and Evans. So we look at map to start off with, which is map is defined such that for any functor, we can have a function from an A to a B. And if you give us a functor, then it can return, map will return you a functor of B. Obviously, the F is the same all through this equation, so it has to be the same functor each time. You can't pass it an array here and expect to get a maybe here. That would violate the functor laws, and really just wouldn't make any sense. So then we talked about chain, which basically is very, very similar, except that in this case, the context that we're on here is chain is a method defined on the monad type class, which when I say type class, if you want to think interface from an OO perspective, you would not be very far off at all. So basically this says for any monad M, if you give us a function from an A to a monad of B, and then you give us a monad of A, then we can return you a monad of B. Apply is a little different. So apply comes from an applicative functor. And basically what we have is that apply says for a functor, if we have a function wrapped in a functor, and you give me a functor of A, I can return you a functor of B. Now that has to be a functor that also implements this apply type class. And this is kind of where the magic happens. But the issue that I have always had with this, understanding this, is why would we ever have a function in a context? Well, as it turns out, it would happen very, very frequently if your language is auto-curried. JavaScript's not, but because we have Ramda, we can basically just say that addition, we just wrap our addition function here in curry, which sounds delicious and does exactly what we want. So our lift function that we showed in episode 25 still works. We can still lift addition into a context. And we can provide maybe of 1 and maybe of 2, and this still works. Just because it's curried, whether it's curried or not does not matter. This still works just like we showed in episode 24. I'm not going to go over too much more with lift, but I will say that lift only works when the context that you're dealing with here implement this apply type class. So how do we get a function into a context, a function into a context that implements apply? Well, pretty simple really. So let's say we have maybe of 1. So we've got a maybe just 1, which we see here in our Repl. I can't cheat. Now once we have that, if we wanted to start calling this addition function, addition doesn't know anything about a context, so we can start calling it with map here. So we're going to provide this A on this map. So this takes a function from A to B and an f of A. We're calling map on the prototype here, but keep in mind this is our f of A, and addition here is this function from A to B. Now if you haven't seen much currying, that's going to sound like I just lied, because surely addition takes 2 arguments. Well, that's where curry gets us. Because what curry is going to do is curry is going to say that addition is a function that if you give it a number, will return you another function that takes another number, and then that will return you the actual result. This is also why you see these arrows. So at any point with this functor for this map, I could do map, provide just the function, and then this could be supplied later. Basically by providing this first argument, it returns a function that will accept this argument and then return this argument. So that's what that's going to do. So great, so now we've mapped addition. And what you see we have is now we have a maybe just of a function. So now we have a function in a context. We can't map over this again because that wouldn't make any sense. We have a function in here. If we were to map over that, we would be providing another function. And for what we're wanting to do, if we're just wanting to fully satisfy this addition function, that wouldn't make any sense. So instead what we can do is we can call .app. We can provide it another applicative functor. Now, just like within lift where we had maybe and maybe here, this maybe and this maybe have to match up. And this would actually work if we had a function that, quote, took 5 arguments. We would map the first one. So we would have our first argument, our first applicative functor, which is our maybe of 1. This is our value in our context. The first call would be the map to the function. And then after that, we would apply, we would call .app, and provide all of the other arguments until we had satisfied the arity of that function. So there you have it. That's the second one. Let me know. Do you like lift or do you like map and apt here? For me, this lift makes a lot more sense. And maybe that's just because I didn't do a good enough job explaining this to you all, and I haven't done a good enough job explaining it to myself. Anyway, thanks for listening. Thanks for watching. This has been episode 25, Applicative Functors and Apply. I'm Reed Evans, and I hope you let me know what you think. Thanks.